Okay, so in this video, we'll see how we can create two nodes of a singly linked list and also link them together. So this is the node format, right? This is the structure for the node format, which we have seen in the previous video. Now, what we'll do is we'll create two nodes. We'll create one node at a time and we'll link them together, okay? So in the previous video, we saw how we can create a single node. Now, a linked list will most of the times consist of multiple nodes. No, not most of the times. All the times it will consist of more than one node. So we have to deal with multiple nodes together, right? So we need to learn how we can link multiple nodes together. So let's see how we can link multiple nodes in a single linked list. So what I'll do is first I'll create a node, right? I'll create a node, and remember the first node of a singly linked list, is pointed to by the head pointer. Now head is not any special name. It is an ordinary identifier. I'm using the name head. You can use the name H, or you can use the name A or B or any legal identifier. Head makes sense. It's a proper variable name, okay, which signifies that head is a pointer which is pointing to the first node of the list. So just to make your program look more readable, you should come up with meaningful variable names. Head is one such meaningful variable name which will only help you to understand what your program is doing and also help others to understand it as well. So I'll be using head as a pointer to point to the first node of the list. You can come up with any name of your own. So what should be the type of head? Since head will be holding the address of a node, the type of head should be same as the type of a node, and the type of node is struct node. So I'll say pointer to struct node. So pointer to struct node. Head is a pointer to struct node. And let's say initially it has a value of null. Remember, pointers can be initialized only with a value of null. So here, initially head does not point to any node. So it's fair enough to give it a null value. Now let's say I create a node. So how do I create a node? I create a node using the malloc function. So I write malloc, and how much space do I need? I need space which is large enough to hold all the members of my structure. Because if I'm able to hold all the members of my structure, I'll be able to allocate a node properly, right? Because my node, what does my node look like? My node looks like this, right? It has a data part and it has a link part. So I should have memory which is large enough to hold the data part as well as the link part. So the size of the structure, the size of this entire structure will be good enough to accommodate the individual members. So I'll say size of struct node. And since malloc returns a void pointer, I need to typecast it to the same type as that of the pointer on the left hand side. Which is the pointer on the left hand side that I see? I see head. And what is the type of head? Struct node star. So malloc should be typecast to struct node star, right? So what will this do? This will create a block of memory because of this statement, okay? Because of this entire statement, I get a block of memory. Let's say the address of the first byte of this block is 100. Now this block will have two parts. The first part is reserved for the data and the next part is reserved for the link. Now this first byte address will be returned and stored inside head. So now head contains 100. So if head contains 100, it is as if head is pointing to the first byte of this block. Now there is a data part and there is a link part which have unknown values because I haven't given them any values myself. So how do I access the data part? This is the data part and this is the link part. So how do I access the data part? I access the data part through the pointer, right? I'll always access a node through a pointer because a node does not have a name. Since a block of memory does not have a name, I have to access it through a pointer. Now the pointer here which is pointing to this block is head. So I'll access this block through head. So I'll say head member access operator or arrow operator data head arrow data equal to 8. Because of this statement, head arrow data equal to 8, what does this statement mean? It means that take the data part of the node to which head is pointing. So head is pointing to which node? Head is pointing to this node. Take the data part of this node and give it a value of 8. So now this data part has a value of 8. Okay. Now see, since I've created a single node, just think about this intuitively. Since I've created a single node, it is the first node, definitely. It is also the last node. Think about it. Pause the video for a moment and think about it. That if I have exactly one node in my list, then it is the first node as well as the last node. Right? I hope you agree with me. So since it is the last node, what is the speciality of the last node of a singly linked list? The last node of a singly linked list will have a null value in its linked part. The last node of a singly linked list will have a null value in its linked part. Now this linked list now consists of exactly one node. So this is the first node as well as the last node. Since it is the last node, the linked part will contain a value of null. So I have to access the linked part. So how do I access the linked part? Through a pointer. Which is the pointer that is pointing to this node? Head. So I access it. I access the linked part through head. So I say head arrow link is equal to null. That means the node to which head is pointing, take its linked part and give it a value of null. So null can be represented using the ground symbol, and that is what I've done here. Right? So I hope up to this point it's clear. Now let's say I want to create a second node and I want to link it with the first node. So how do I do that? That means I want a node here. Let's say I want a node here. I want a node here and I want to link these two nodes. So how can I link a node? How can I link two nodes? How can I link two nodes? I can link two nodes by taking the address of this node. Let's say the address of this node is 200. By taking the address of this node and putting it in the linked part of the previous node. So if I take this node and in its linked part, if I assign the value 200, somehow if I'm able to create this node in such a way that the address that is returned is stored in the linked part of this node, then I'm able to link the two nodes. I'll repeat. If somehow I can create this new node such that the address of this node is stored in the link part of the previous node, then I'll be able to connect the two nodes. So let's see how we can do that. So I want the address of this node. So how will I get the address of this node? When I use malloc, malloc will return the address of the first byte. So what I can say is, I can say malloc. So how much space do I need? Same as I've shown you here. Space which is large enough to hold all members of the structure. So I say size of struct node. And now what should be the return type? Obviously the return type has to be of the same type as the node. Now the type of the node is struct node. So the return type will also be a pointer to struct node. So struct node star. And here, so what will malloc do? It will return the address of the first byte. And the address of the first byte is, let's say it's 200. Let's assume that it's 200. So where should this 200 go? This 200 should go in the linked part. Now, how can I access the linked part? I can access the linked part through head. I can say head arrow link. So here, if I say head arrow link, it would mean that allocate a block of memory and return the address of the first byte to the node to which head is pointing, and return the address where? To the link part of the node to which head is pointing. See, this will allocate a block of memory and it will return the address of the first byte of the allocated space, and it will store it in the link part of the node to which head is pointing. So currently head is pointing to this node. Now the address which is returned will have to be stored in the link part of the node to which head is pointing. Since head is pointing to this node, its link part is this part. So this 200 which is returned through malloc will have to be stored here. So if 200 is stored here, there is a link which is formed. Right? Now this node is no longer my last node. This is my last node. So how do I access the link part. So I have to make this link part null, right? The link part of the last node is null. So I have to somehow access this node's link part and make it null. So how do I do that? Through head. So I'll say, now look at this carefully. So if I say head, head has a value of 100. That means I'm talking about this node. If I say head arrow link has a value of 200. That means I'm talking about this node. And I want to set the link part of this node to null. So first I'll have to access this node. How do I access this node standing here? I can access this node standing at this node by using the link part of this node. So I can say head arrow link. So when I say head arrow link, it means take the link part of the node, to which head is pointing. So head is pointing to this node, take its link part. So this part, take its link part. Now the link part is 200. Now this 200 means this node. So currently I'm accessing this node. By 200 I'm accessing this node. And now I want to assign its link part. So I'll take another link and give it a value of null. So I hope this is understood, right? So head arrow link means this part. Now this part resembles this node. Now I want this node's link part. So head arrow link will give me this node. Now this node's link part means another level of link. And I want to give it a value of null. So this part gets a value of null. And what about assigning a value to this data part? So I'll say head arrow link. So head arrow link means this node. Head arrow link is 200. That means it's this node. Arrow data. Let's say I give it a value of 12. So now because of this statement, this part gets a value of 12. So this is how you can link nodes in a linked list. So I hope this helps. I'm sure you'll have your doubts, and I would request you to leave them in the comment section below. Thank you.